Good evening, dear all. As I say in all my videos which are shared and uploaded, that for any entrance exam, we have to concentrate on the concepts of NCERT. With the same concept, I have already uploaded a video on March 8, 2025. This same type of question has appeared in a NEET 4th May 2025 paper, which is having the exact numerical which I have solved of the chapter number 1, video number part 4, Coulomb's law, numericals. So you can please go and see this particular video. This question I have solved at 3 minutes 40 seconds. Now I am here to just make a statement which every student must understand, that you must learn the concept of NCERT to solve any entrance. Okay, that is what I am trying to convey to each and every student of standard 12. Fine. Now let us see this video first, and in the later part of the video I shall complete the numerical which was asked in NEET 2025 with small variation of the numerical which I have already solved and uploaded in my video. Fine. Now let us do a few numericals based on Coulomb's law, where we will try to connect theory to the numerical and numerical to the theory as a complete package of theory and numerical. So try to do that while studying itself. Okay, so let us talk about the numerical shown here. We have two insulated charged copper spheres A and B of identical size, having charges QA and QB respectively. So let us draw two identical spheres A and B with the charges QA and QB respectively as given. Now let us read the next sentence. A third sphere C of the same size, means identical, but uncharged, is brought in contact with the first and then in contact with the second and finally removed from both. Okay, so which means that I have third sphere which is uncharged, naming C, but it is identical to A and B. This sphere C, as read here, is first brought in contact with A, then in contact with B, and then released, as read in the sentence number 2. So when A comes in contact with C, according to the theory of conduction which we learned in the theory part, both the charges or both the spheres will get equal charges. So the charge on the sphere A will be QA by 2 and the charge on sphere C will also be QA by 2. Now this sphere C is removed from A and kept in contact with B. So this sphere C has QA upon 2. It was originally uncharged and now we are keeping it in contact with B. So the new charge on B and C will be addition of both divided by 2. So the sphere B will have QB plus QA upon 2 divided by 2. Similarly, the sphere C will also have QA by 2 plus QB divided by 2. So the question here is, what is the new charge on A and B? The new charge on A is QA by 2. The new charge on B is QA upon 2 plus QB. As per conduction, it should be distributed equally, so I divide by 2. They can also ask, which is not asked here, what is the charge on C? The charge on C is also the same, because in the end the sphere C was detached both from A and B. It took half charge from here, it took another charge from here, divided by 2. Okay? In the end, one more extension of the question can be, what is the force between these two charges A and B now? Given the distance between them is R. That can be an extended question. As I said, make your own questions. So they have made us find out the charge on A, the charge on B. We made a distance of R between them. So what is the force between these two charges? F is equal to K. What is our first charge? QA by 2. What is our next charge? QA upon 2 plus QB divided by R square. Okay? So this part of question I have extended. What is the charge on C? This part of question also I have extended. What is the force between the two charges after this whole process was done? So I wrote K Q1 Q2 by the distance square. So that kind of question also can be asked. As can be seen on the board, this is the same question given in NEET May 4th, 2025. Here there is only one variation, that the charge is equal to Q and the force of these charges is F, where you can see the identical charge conducting bodies A and B, spheres A and B with charge Q. That is the only variation, and here we have to find out what is the force with the new arrangement, in which we had already solved this in the video seen just now. A, I solved it as QA upon 2. B, I solved it as QA upon 2 plus QB. Substituting QA is equal to QB is equal to Q, we find F, which is the original force, as K Q upon distance square R square, which is equal to K Q square upon R square. After making the variation, F dash with QA is equal to, as can be, QA dash is equal to, as can be seen from here, Q upon 2. QB dash is equal to Q upon 2 plus Q again upon 2, such that QB dash is equal to 3Q upon 4. So we have QA dash, the new charge on the sphere A, is equal to Q upon 2, as substituted Q here, and QB dash is equal to 3Q upon 4 upon the sphere B. Now finding out F dash, we have K QA dash QB dash upon R square, which is equal to K Q by 2 multiplied by 3Q by 4 upon R square, such that 3 upon 8 K Q square upon R square is our new force F dash. Okay, and F dash is equal to 3 upon 8 F, where F is equal to K Q square upon R square, as can be seen there. So the option to be marked in the exam is number 4 with the answer 3F upon 8. So in this way, you must first learn the concept of NCERT, solve the numericals based on that concept in the textbook, and slowly practice them so that in the entrance or the board exam it will become very easy for you. Fine. To watch such videos and connect the theory with the numericals, please subscribe my channel Physics with Dhanu Saraiya and arrange the concept and the numericals in your mind so that you can perform better in the entrance as well as CBSE also. Okay, so I just move now and you can take a screenshot of what we have just now calculated. Fine.